Cars! They're more than just chunks of metal on wheels. They're finely tuned machines, and at the heart of every car lies the engine. It's the beating heart, the source of power, the thing that turns petrol dreams into rubber-burning reality. Engines are complex beasts, but don't worry, we'll break it down for you. From humble hatchbacks to roaring supercars, every car relies on an engine to propel it forward. These mechanical marvels come in all shapes and sizes, each with its quirks and character. But whether it's a purring electric motor or a growling V8, the basic principle remains the same. Convert energy into motion. Think of it like this. You eat food for energy, right? Well, engines guzzle fuel, and through a series of controlled explosions they transform that fuel into the force that turns your wheels. It's a beautiful, violent dance of physics and engineering, and it's what makes driving so exhilarating. So buckle up as we delve into the fascinating world of car engines. We'll explore the different types, how they work their magic, and why some engines are built for pure, unadulterated speed. Get ready to unleash your inner petrol head. Let's get down to the nitty-gritty. Internal combustion. Sounds scary, right? Don't worry, it's just a fancy name for how most car engines work. Picture this. A small enclosed space called a cylinder. Inside, a piston goes up and down like a metal woodpecker on a mission. Here's the action sequence. First, a mix of air and fuel is sucked into the cylinder. Then the piston compresses this mixture, squeezing it tight. Next comes the spark plug, igniting the compressed mix in a mini explosion. Boom! This explosion forces the piston back down, and this up and down dance is the engine's heartbeat. This motion, repeated hundreds of times per minute, is transferred to the crankshaft, a spinning rod that's connected to the wheels. It's like a relay race, with the piston handing off the energy baton to the crankshaft, and finally to the wheels, propelling you forward. This whole process from sucking in air to spinning the wheels is called a cycle. Most car engines use a 4-stroke cycle, meaning the piston goes up and down twice for every explosion. It's a symphony of controlled chaos, and it's what makes your car move. Now let's talk about the numbers that make petrolheads drool: power, torque, and RPM. These three are like the holy trinity of engine performance, and understanding them is key to unlocking the secrets of how cars go fast. Power, measured in horsepower, is like the engine's muscle. It tells you how quickly the engine can do work, or in simpler terms, how fast it can make your car go. The more horsepower, the faster the acceleration, and the higher the top speed. Think of a cheetah, all about raw speed. Torque, on the other hand, is the twisting force the engine produces. It's the grunt, the pulling power, the thing that helps you climb hills or tow heavy loads. A high-torque engine is like an ox, capable of pulling massive weight. Finally, we have RPM, or revolutions per minute. This measures how fast the engine is spinning. Higher RPM means more explosions per minute, which usually translates to more power. Think of it like a drummer. The faster they hit the drums, the louder the sound. These three factors are all interconnected like a complex dance. An engine that revs high might not have a lot of torque down low, and vice versa. Understanding this interplay is what separates casual drivers from true petrol heads. Section 4, Engine Layouts. Finding the perfect balance. Engines, much like people, come in different shapes and sizes, but unlike us, their physique directly impacts their performance. We're talking about engine layouts, the way cylinders are arranged, and how that affects power delivery and overall character. The most common layout is the inline-4, where all 4 cylinders are lined up in a row. Simple, compact, and fuel-efficient, it's the workhorse of the car world. Then there's the V6, with cylinders arranged in a V shape. Smoother and more powerful than the inline-4, it's a popular choice for family cars and sports sedans. For the true petrol head, nothing beats the sound and fury of a V8. With 8 cylinders arranged in a V, it's all about raw power and a symphony of exhaust notes. And then there are the more exotic layouts like the Flat 6, known for its low center of gravity and perfect balance found in legendary sports cars. Each layout has its pros and cons, affecting everything from power delivery to handling. It's like choosing the right tool for the job. Want a fuel-sipping commuter? Inline-4. Craving tire-shredding performance? V8 all the way. Section 5, Forced Induction, Turbocharging and Supercharging. Want more power and speed? That's where forced induction comes in. Imagine using a pump to inflate a balloon faster. Forced induction forces more air into the engine for more power. 2 main ways, turbocharging and supercharging. Turbochargers use exhaust gases but can have turbo lag. Superchargers are belt-driven, offering instant power. Turbo is like a cheetah, supercharger like a lion. Both have pros and cons, but both mean more power. It's like turning up the volume on your favorite song. Section 6. Aerodynamics, slicing through the air. Here's a secret. Going fast isn't just about horsepower, it's also about how well you cheat the wind. Enter aerodynamics, the science of making cars slip through the air with minimal resistance. Think of a fish darting through water. It's streamlined, minimizing drag. Cars, especially at high speeds, face similar resistance from the air. Aerodynamics is about smoothing out those bumps, minimizing drag, and even using the air to push the car down for better grip. This is where spoilers, diffusers, and those sleek, sculpted body lines come in. They're not just for show, they're functional elements directing airflow to reduce drag, increase downforce, and improve stability. It's the difference between swimming through syrup and gliding through water. Good aerodynamics means less energy wasted fighting the air, leading to better fuel efficiency and higher top speeds. It's why race cars look like they're from another planet, all wings and curves. They're designed to cheat the wind and achieve the impossible on the track. Section 7. Race cars and high-speed engines built for extremes. Now let's talk about the kings of speed race cars. These machines are the epitome of high-performance engineering designed to scream at the red line. Race car engines push the limits, rev higher, produce more power, and endure extreme stresses, crafted from exotic materials meticulously balanced and tuned to perfection. Like a sprinter built for short bursts of extreme speed, it's not just about power, reliability is key. Engines are rigorously tested and rebuilt to handle motorsport demands, a symphony of precision engineering, balancing power and reliability for the checkered flag.